Hello friends, let us see the last problem on infinite slopes. So first understand the problem. What is given here? It is given that an infinite slope, okay, made up of the granular soil. That means again they are saying that it is a granular soil. It's like a previous problem, right? G value same, E value same, phi value same. That means only the conditions of the soil is different. So again we can call it as a cohesionless soil. That means we can say cohesion will be equal to 0. And what is given data? Properties of the soil. Again, G is given as 2.60. Void ratio is given as 0.4. Angle of friction is given as 30 degrees. Okay. After that, what we have to find? We have to determine the factor of safety available on a plane, okay, parallel to the ground surface at a depth of 5 meters. That means if you draw an inclined infinite slope, you have to find out factor of safety on a plane. Let us say this is parallel to the surface that is at a depth of 5 meters from the ground surface. So on this plane, you have to find out what is your factor of safety. Okay. What is the factor of safety acting on that plane? You have to find out. Okay. The depth of the failure plane is given, that is given as 5 meters. Okay, fine. So according to our notation, this depth of the failure plane, we are considering it as a h. That will be given as 5 meter. Okay. And what is given? If seepage occurs parallel to the slope. Okay. Seepage occurring parallel to the slope with water table at a depth of 2 meters from ground surface. That means there is a seepage flow. That means it is not complete. The seepage is not completely up to the surface level. It is up to some part of the slope only. So up to that much, it is 2 meters from the ground surface. So from here to here, it is 2 meters. If you remember, while doing the derivation part, we have considered the jet value from water table to the failure plane. But what is the value given in the question? This is the distance from ground surface to the water table. But while deriving the derivation, we have taken distance from failure plane to the water table. So what is this much? Total is 5 meter. After those, if you neglect 3 meter, how much you will get? 5 minus 2. So according to our convention, jet value is nothing but a 3 meter. And what is given under that? Slope of the surface is given how much? 25 degrees. So if this is the case, what is the factor of safety? So if you recall the formula, if it is a seepage, factor of safety, that will be written as 1 minus gamma W into Z divided by average weight density into H into tan phi divided by tan I. Okay. What is the phi value given? Phi value given in the question is 30 degrees. Okay. I value given is 25 degrees. H value given as 5 meter. 3 value given as 3 meter. And okay, this tan phi as we can find. So what is the values we have to find out here? So here we have to find out what is the gamma average value, isn't it? So what is the properties of the soil given? First, let us recall them. G will be equal to 2.60 and void ratio will be equal to 0.4. Okay. Let us redraw the given conditions. Okay. Okay. This is a seepage level. Or else let me draw with some different color. Okay. Up to this, seepage is occurring on the soil in the downward direction. So from here to here, the soil is in which state? It is in the dry state. That means which value we have to use? So in this state, we have to use the dry weight density. In this state, the soil is it is completely filled with the water because the seepage flow is occurring. So here we are having the saturated state. As we are having the saturated state, we have to use the saturated weight density. Okay. So dry state is represented by gamma D, saturated state is represented by gamma sat. Whatever the distance is, from here to here, if you observe, this is 2 meter. From here to here, if you see the problem, it will be 3 meter. So what about the gamma average value? How can we write it down? Gamma average is nothing but a weighted average. That means what is the length up to which gamma D is acting? 2 meter. That means 2 into gamma D plus what about the depth of the saturated soil? 3 meters. So 3 into gamma saturated divided by what is the total depth of the soil? That will be 5 meter, isn't it? So if you want to find out the gamma average, first you have to find out gamma D and also you have to find out gamma saturation. So let us find out those values. So from the properties of the soil, we can say gamma D will be equal to G into gamma W divided by 1 plus E. G value given as 2.6. Let us take unit weight of the water as 9.81 kilonewton per meter cube. So what about the void ratio? 0.4. If you solve this, you will get this value as 18.21 kilonewton per meter cube. Similarly, if you find out gamma saturation, that will be equal to, again recall this, G plus C divided by 1 plus C into gamma W. Again substitute G value and E value. If you do that, we will get the value 21.02 kilonewton per meter cube. That's it. Find out the average weight density. So average weight density is nothing but according to the formula 2 into gamma D. Gamma D is 18.21 plus 3 into gamma saturation 21.02 divided by what is the total depth of the soil? 5. That can be, if you do that, you will get 19.89 kilonewton per meter cube. That's it. Now we got all the parameters. Now substitute all the parameters in this equation. 1 minus gamma W into Z divided by. So once again, I am writing the equation. Factor of safety will be equal to 1 minus gamma W into Z divided by average value into H complete multiplied by the tan phi divided by tan I. So if you substitute the values, 1 minus weight density of water 9.81 kilonewton per meter cube into what about the Z value we have found out, that will be nothing but a 3. What is the average value we have found out? That will be 19.81. What about the H value? 5, right? Into what is the angle of friction given? 30 degrees tan 30. What is the slope of the surface? That will be tan 25. So if you substitute these values, then you will get factor of safety as 0.867. Now observe this value. Is it greater than 1 or less than 1? So here we are getting factor of safety is less than 1. That means it is not a stable slope. That means because of this seepage flow, landslides will occur on this case. Just substitute the formulas. Just remember, we have to remember the formulas, and also you have to remember that Z is from distance from failure plane to the water table level. H is nothing but a depth of the failure plane from the ground surface. We have to remember these terms clearly. If you do not remember them, then you may enter in the wrong data and then we may end up with the different results. So please make sure to remember whatever the terms in the formulae. Okay, such that you will not commit any mistake. Okay, thank you.